Welcome everyone to this week's latest in Bitcoin Tech session. Today we'll continue with what we started off last week. That is trying to understand about Stratum V1, and last week we looked at the pool mining protocol Stratum V1. We looked at different messages that gets exchanged between the miner and the pool, and so we saw it via an example picked up from the bit access logs. So today we'll continue with that. What we'll do today is that we'll particularly try to understand the issues associated with V1 itself, and what sort of solution does Stratum V2, the new pool mining protocol that is being developed and being deployed, what solution does it offer? So we'll stick to the stick to we'll stick to a top level, not go too deep into V2 itself. I think trying first, it's better to understand what V1 has issues with, and how V2 proposes to solve these things. So that will be a good uh, uh, top level understanding to begin with. So there are I think some 5 or 6 major issues associated with V1. We'll describe each one of the issues associated, and also the solution that V2 engineers. So the first one is that there is no transport security associated with uh, V1. What do we mean by that? Last week we saw. Let me open the last week's illustration that we saw. So last week we saw all these messages: miner, TCP connect, mining configure, mining subscribe, and whatever you see here are all the actual messages that get passed between the client and the server, which is client is nothing but the miner, and the server is nothing but the pool. So if you can see, um, all these texts that are being sent are human readable and also machine readable. There is no encryption, or there is no hiding or anything happening here. So so that's where it is. So the issue is that V1 runs over plain TCP. So V1 runs over plain TCP. Uh, it doesn't have any built-in encryption or authentication. So as we see here, it's all plain text, and most of the information are like easily readable if somebody sits in between the server and the client. So what problem does it lead to is that it can lead to man in the middle attacks, because the information shared between the server and the client are all in plain text. Also, it can lead to hash rate hijacking. How an attacker can do that is that by learning all the information shared between the miner and the pool, the the attacker can insert himself as a false pool or a proxy pool, and then divert or steal hash rate from the miner. The miner might be thinking that he's actually mining for the pool that he decided to, but in reality he will be mining for the attacker's pool. So these kinds of problems are possible. So um, all this is because these communications are like open and plain text. So that's a major problem with Stratum V1 protocol that we have right now. Stratum V2 proposes a solution to solve this. So first thing is that the basic thing is that you have to encrypt these exchange of messages between your client and the server. So what does Stratum V2 do is that it provides an AED encryption in its protocol. So which is authenticated encryption with associated data. So it's a encryption data scheme. We'll not go into the details of what AED is and how it works. So before transmitting any sensitive or any information between the miner and the pool, after setting up the basic TCP connection, the protocol immediately goes into setting up the AED setup. So once this encryption is set up, henceforth all messages from the miner to the pool and pool to the miner will become encrypted. So this adds a very this is a very step means very huge improvement in the protocol in the mining protocols design. So once this AED is set up, all other communications such as the mining dot subscribe, mining dot configure, mining dot authorize, where you share the username, password, etc. They are all encrypted. In V1, here you can see it's all in plain text. Particularly this mining dot authorize message, if you can see, it the if you just sit in between the miner and the protocol, anybody who is sitting, let it be your ISP or an attacker, if he looks at the packets exchange between you and the pool, he can see all these information. So first things first, when you introduce AED encryption, it encrypts the entire connection between you and the miner, and nobody can see what is going on in between it. So there is an initial handshake between the miner and the pool. That's where the encryption is set up, and once it's set up, then there will be no leakage of information. So this is the first problem of transport security, and this is how Stratum V2 solves for this first problem. The second problem is exposed credentials. As we saw here in the mining.authorize message exchange in Stratum V1, here you can clearly see that the miner left side is sending its username password to the uh, to the pool. The issue is that all these things are in plain text. Usually, the username that a miner sends to its pool will be the payout address in which it wants to receive the block reward or its shares. So that one also gets exposed. So your the address in which you hope to receive a block reward or your fair share for contributing the pool, that one is also in plain text in Stratum V1. So that is a big problem. Um, so apart from your username and password, there is also a bunch of stuff that gets revealed. For example, in the mining.subscribe, usually your miner will send what type of miner it is. So, for example, it's in a bitax. This is what it usually sends. It sends that I am a bitax and I am using BM1370, which is nothing but the A6 model number. So these kinds of information also gets leaked. And also it also sends the port number in which it connects. So that information also gets leaked. Also when it is submitting when a miner is submitting its share, uh, when it does this ASIC mining dot submit. So these are all the shares that it submits. So these things also gets revealed. So these are no, you are not supposed to like an attacker can use this information to do malicious stuffs. So it is better to encrypt all these things. So how does it happen? As we saw in this solution, when this handshake happens and then authenticated encryption is established between the miner and the pool, that all these datas become encrypted. So that's how the exposed credentials problem that exists with Stratum V1 gets solved in Stratum V2. And so the third problem is verbose JSON. So if you all know about JSON, JSON is nothing but a way of sending value and data pairs. So, for example, if you see here, ID is to null. This ID is the key and null is the value. So these are value key pairs. For ID is one key and null is the value. Method is a key. Mining notify is the value. Params is a key, and these are all the parameters, and they are the value. So JSON is nothing but this structure. Um, mining SV1 uses JSON completely. That means whenever whenever the miner wants to establish or transmit any data to the uh, pool, it does this via a JSON construct. So because it uses JSON construct extensively, uh, it is not very efficient. Even though it's easy to construct and read, it is not an efficient method or efficient data structure to use when you are communicating between a server and a client. uh, so it consists of a lot of data, uh, per usually many kbs per message, as we saw here. For example, this mining.notify. If you see mining.submit message, if you see here, you have a lot of key value pairs. So these are all heavy or dense data transmission in communication parlance. So this is not a very efficient means to communicate between the miner and the pool. So because of this, what the other problem is that because JSONs are data heavy, it is typically not possible to design an ASIC to handle all these things. So if you see here, what the idea is that just a minute. Yeah. So if you see in a bitax, you'll see a small square patch here. So this is an ESP32 microcontroller, and the actual ASIC sits beneath the heatsink. What is of importance is that because using JSON, it is necessary to have a microcontroller or an MCU that that does all the JSON processing. Typically, an ASIC will only do double SHA 256, and it can't. It doesn't have the architecture to perform parsing of JSONs. So, because we are using JSON, there is a definite need of a, somewhat powerful uh, microcontroller as an ESP32 that we see in our BitAx. Uh, Large miners have much more powerful parsing processors in their control boards. So now it's a, because of these kinds of structure, it's a two system kind of thing setup where you need a MCU to do a lot of processing before communicating, and it has to convert all the stuff that it receives from the pool, make a package and send that package to the ASIC. So the ASIC does the hash and gives the hash back, and the MCU or the microcontroller broadcasts it. So so these are all the reason, because of this inefficient data type that SV1 uses. There is currently a need for these two types of units in your miner. But if but by switching to SV2, where it uses binary data frames, it is possible in the future to design ASICs that does these functions internally, which is like um, receiving communication from a pool and then processing the received data from the pool and creating work packages from the received data and hashing it and then sending it back to the pool. So it is right now it's not possible because ASICs are designed in this way. In future, it is possible that it is possible that the ASIC itself can handle all these types of jobs. So how does Stratum V2 propose to change this JSON heavy data structure is by using a data frame. So what this data frame typically consists of is it consists of four fields. One is your extension type. Then comes your message type, message length, and the payload itself. So it's a very generic or top level data frame design. uh, you can use this data frame to put different types of data that you want to send and receive between the pool and the miner. So this extension type will define what sort of job or template or basic handshake communication that happens between the pool and the miner. Um, uh, Anything can be like defined within these four fields. So this first thing you describe what is the type of the message that you are going to send. Let it be a handshake message, or let it be a encryption establishment message, or let it be actual mining job transmitting message, whatever you can define it. Then you have the message's length. So the extension type and message type are used to define these two. Then the length of the payload that you are going to send and the payload itself. So this payload can be, if you want to compare it with SV1, for example, this mining dot subscribe will be translated into a this mining dot subscribe will have a extension type and a message type, and the message length will be this parameters length. So this whole thing's length will be encoded in this data frame, and finally the payload will be this whole bitags details itself. So this is how this mining dot subscribe will be converted into a data frame in Stratum V2. So it's a kind of a low level envelope that wraps all the SV message types, and this can be sent over the TCP as a byte stream. So this all these things will be constructed, and then it will be constructed into a byte stream, ones and zeros, and then it will be sent via the connection between the mine pool and the server. So this is an important difference that Stratum V2 brings in. So I'll pause for a second. If there are any questions, I'll take. Yeah, Crackdev, we are looking at Stratum V2 protocol. Particularly, we are looking at the problems associated with Stratum V1 and how Stratum V2 is solving it. Last week, we saw about Stratum V1 itself. So that's what I'm using to explain. So this is typically Stratum V1, how Stratum V1 protocol works. You connect, and then you set up configurations, then you subscribe, then you authorize, then you set difficulty, then you start mining. and then you communicate the results. So this is how V1 works. So now we are looking at the problems associated with V1 and how V2 is trying to solve it. So the fourth problem that V1 has is with respect to scalability. So now the communication established between the miner and the pool uh, is via TCP, and it has the TCP's design is such that your client or your miner will request for a connection or a socket with the server, that is your mining pool, and the server will allocate a socket, that is a designated uh, you can imagine like a designated plug in which uh, each miner goes and plugs into. Um, um, each minus switch goes and plugs into. So that's the kind of architecture currently what exists SV1 Stratum V1. So when this initial handshaking happens, that is here in the TCP connect process, all these details are exchanged and a connection is set up. So each miner will have a direct connection, its own direct connection between the between it and the pool. So at least for the session or till the miner disconnects, this switch or this connection is fixed, and uh, whenever a second miner wants to connect with the pool, it will also have to establish and hope that the pool allocates a dedicated line and a switch to it, the new miner. The problem is that this is currently not scalable. Maintaining a huge a table of sockets is resource consuming for the pool, uh, and also the pool has to parse JSON data from each of these miners, so that's also resource consuming. And the pool has to broadcast, let's say for example the pool is now mining some, let's say 954,600 the block. The pool has to broadcast the information about what the miner has to do, which is typically same. The block template, the coin based transaction, everything is same. But because of the nature of the connection, where each miner gets one single socket, the pool has to pump this information into the thousands of sockets that it has with the miners. So that is also very inefficient. So that's also very inefficient. So um, that's also a problem with SV1 currently. uh, and there is no clean way to aggregate all this information. Typically there is no clean way to multiplex all these connections, so that the server can like deal with one single connection while uh, multiple pools or the multiple clients come and plug into it. So this is a but currently how pool miners deal with this is that they have their own implementation of proxies that sits in between the pool's node and the clients. So this proxy is custom made by each of the pool operators, and it's not standard, and it will vary depending upon the pool. So there is no uniformity with respect to this problem. So that is the scalability issue associated with SV1. So how does SV2 solve for this is that it specifies the proxy and the topology that the pools and the pool should follow. Um, the proxy, what the proxy does is that it aggregates many downstream miners into few upstream connections. You can imagine like 5 or 10 connection comes into this proxy, and then this proxy makes one single connection to the pool. Similarly, there will be like you can imagine batches of these connections coming in and eventually establishing communication with the pool. So this is done via using communication channels. So these channels identify for each mining session, and these channels can also be grouped to share messages. So that's how the proxy setup is for SV2, and this sort of solves the scalability issue associated with SV1. Then comes the famous problem which SV2 is known for. SV1, SV1 in SV1, it is technically not like it's difficult or technically not possible for a pool to delegate uh, the construction of block template to the miners itself. So the miner has to be running a node in order to construct the block template himself. Otherwise, he'll have to, which means he's effectively solo mining. Otherwise, he'll have to take whatever the block template that the pool serves him. That is because the protocol itself is like this. So so you can see in the mining.notify uh, mining.notify message when it happens. So so this happens from the pool to the miner. So it sends a bunch of stuffs like the previous hash, which is so this previous hash decides on which chain tip does a miner have to perform or do the next work. Then you have the Coinbase 1 and Coinbase 2 data fields. So this pretty much fixes fixes what the miner can mine on, and then the Merkle branch also gets served to the miner. So when a Merkle branch gets served to the miner, that means you cannot choose your transactions from the mempool. So this is already chosen, and it is sent or served to you. So 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 this is the problem that is associated with SV1, where all these details are sent to you, and you can't do much about it. You can't do much about it. Uh, so this is where like the Coinbase, this is where SV2 comes in. So what SV2 does is that what SV2 does is that it breaks up all these jobs into pieces. So the template distribution, it divides the SV1 into SV1's miner.notify function that we see here into two parts, which is template distribution and job declaration. So at a top level, template distribution is nothing but saying saying to the uh, saying to the pool that that the miner says to the pool that get me a candidate block template from a full node, which is a pool. And job declaration is nothing but you tell the pool once you do template distribution, the pool sends you a bunch of templates details about the template, and then you tell the pool which template I intend to mine, which is like you communicate back to the pool details about the Coinbase transaction, the Merkle route, and stuff like that. So in this there are
Bala,
a bunch of yeah.
can I ask questions here or at the end of
Yeah,
the
yeah.
session?
No, you can ask.
So these pools of templates,
Yeah,
how does, like, because there's only one pool coordinator, so
yeah,
they, rather than giving one template, they select, they select in this case multiple templates, right?
yeah. No,
So again, there's some sort of centralization because it's a pool maintainer who is selecting templates. Earlier they were selecting one, now they're selecting a few.
no. You the template provider is a service that can be spun up. Like now you can imagine earlier. Now here we are seeing like only two parties involved. One is your miner and the other is a pool. So, but now here a third party sort of comes in. So, a template provider service. So, this can be the pool itself, or this can be the template provider, can be somebody else who serves you templates. So you can have your own template provider. Like for example, if you are a miner and you have like the miner itself can't do these jobs. Like Bitax can't construct templates. So the template has to be constructed in another device, which is of course has to be a full node. It has to have a mempool, and it has to be running Stratum V2 protocol. So now you have to imagine about a device that sits between you and the pool itself. So you can take templates from this provider, work on the template, mine, and then send the results of the mining to the pool. Was it helpful, Sidhu?
Okay. Yeah, there's another party now, which could
Yeah,
be the pool maintainer
yeah.
or someone else could also play that role. Cool.
The whole idea is that in future there will be multiple vendors who will be serving you templates, and you can use their service. Or if you are a big enough miner, like you can set up a template provider yourself and send, like you have 10 miners at your home, you can spin up a template provider at your home, and then this template provider will serve block templates to your home miners, and your home miner can like mine on these block templates and submit the hashes to the pool itself. That's the construction that SV2 is moving towards. So you have template providers, then you have job declarator clients and job declaration servers. So these are all the job declarator client receives templates from the template provider. It can declare how it is constructing the block template to the pool, and the job declaration server is typically at the side of the pool. So its job is typically to verify whether the pool's constraints are enforced. If the pool might have specific payout rules, the job declaration server will enforce those rules. Then it also verifies whether the hash that you have sent back to the pool is correct, and whether it can be counted as a share, and also it can validate the shares. uh, and suppose the share is less than the network's difficulty, that means you have mined a block, and it will also broadcast those blocks to the network and declare that you have mined the block. So that's how Stratum V2 is decentralizing the block construction and the verification part of it. So you can think of now three instead of two here. So there are just two entities here sending messages back and forth. Instead of that, now you can imagine three entities. The template provider um, will sit somewhere in between, It can be a third party, it can be you yourself running a template provider, or it can be the pool running a template provider that serves you templates. So currently, Ocean Mining sort of does that in their datum protocol. So Ocean Mining is a pool, and they provide you an option of templates to choose from. So I think they provide you three different templates. One is completely devoid of any data transactions. Not yeah, completely devoid of data transaction, only monetary transaction. Second one, um, I think it's sort of. I think they have that regular 83 byte uh, operator limit, and the third one is your regular core V30 type of block. So you can choose. I think they have different incentive structures for each of these blocks. So you'll get the best payouts from Motion if you choose blocks with no data, and you'll get the least payouts. Means the fees are high if you choose to mine a block containing non-monetary transactions. That's how Datum does it. But because there is no standard protocol to do all these things, like Stratum V2 is proposing, um, how Datum does is that they have their own implementation of Stratum V1, and that's proprietary, and that's not for open source, and they use that to serve these types of data to your miner. So your miner will typically see only mining.notify and async.results kind of thing. Your miner doesn't have to have a special firmware to understand what Datum sends you, but uh, choosing these block templates and all those things you have to do online, like on the you have to log in into your Datum login, and then you have to perform, like you have to choose what you want to mine, and once you have set it up, then it will then Datum will sort of serve you that type of block templates. So once V2 is extensively used, this template provisions, the template provider will become another third party. It will become modular. So there can be only template servers, like providers of template. It can become a service itself where you construct templates for people to mine on, and probably you'll charge some small fees for doing that job, and miners can pick that template and then submit shares to any pool that they want, like they don't have to stick to the pool's own template, and the pool also doesn't have, if it's a Stratum V2 pool, the pool also doesn't lose anything or stand to lose anything uh, by not like if a miner doesn't use its template, the pool also doesn't stand to lose anything monetarily, because whatever block is constructed will also optimize for maximum fees and stuff like that. So that we have to, that nobody knows like how it will pan out. So if there are non let's say non-economical template providers, how it will go, we don't know. So that's about the block template construction, and also the final problem is about extensibility. Right now, this Stratum V1 is very constrained, or there is very little scope for adding new features. So that is why, like, we had to create a completely new protocol, like V2. We cannot like add these whatever features that we discuss now. If Stratum V1 was in the earlier stages designed to be modular, we could have like added these things without requiring a change in the protocol itself. So why V2 is I think it's slow to adopt, is that Ideally speaking, there should be change in your minus firmware itself in order to understand. For example, let's say it talks using data frame. So this is completely new to a V1 firmware. V1 firmware doesn't understand these data frames. So as a stopgap arrangement, what Stratum V2 protocol development does now is that it gives you a translator which you can use, um, that sits between your miner and the pool which serves you Stratum V2 data. So that so the translator will act as a mediator between your miner, which understands only Stratum V1, and the pool which understands only Stratum V2. So that is a kind of a gap that needs to be bridged. Um, mm, from the miners side, manufacturer's side, or let's say an ant miner or watts miner, or for home miners, let's say bitax, the firmware has to be rewritten in order to understand this new protocol. So this is one of the reasons why Stratum V2 is being designed with capabilities to add new features as and when needed, so that you don't have to do this is kind of a hard fork now. You have to without the translator, now you have to perform, it's like performing a hard fork. You have to force all the miners to rewrite their firmwares in millions of miners out there, and the adoption has to be uniform, and it's a logistical challenge. So that's why V2 adoption is slow to pick up, even though it offers a lot of benefits. Like um, right now, for us to see that V1 does all this sort of communication in plain text, it might be like crazy for us to even think about it, but that's how V1 has evolved, and that's the state at which V1 is. If you consider rest of the peer-to-peer protocols of in Bitcoin itself, when you consider the rest of the places where P2P exchange happens, this is kind of very primitive. So the mining protocol exchange is kind of very primitive, and that's where it currently stands. That's also primarily because of the lot of overhead associated with the upgradation. So, so that's all the features that I had to share today.